Today we will discuss numerical on motion of electron in electric field. For that we have considered two plates A and B. The upper plate is positive and the lower plate is negative. That's why there will be electric field between the two plates directed from positive to negative, and the electric field is denoted by E. If the potential between the upper plate and lower plate is denoted by capital V, and the separation between the two plate is D, in that case the electric field developed between the two plate is that E is equal to V by D. Now if a fast moving electron is allowed to enter in this region with velocity v, then the path of the electron will be deviated from its actual straight line path. The path will be directed towards the positive end, towards the positive terminal, because of the attraction force from the positive terminals. So the force on the electron due to positive terminal is given by F is equal to charge of electron into electric field E. This will create an acceleration on the electron in upward direction given by F by m, where m is the mass of the electron. Because of this force in upward direction, the electron is found to be deflected from its original direction in upward path, and the deflection is denoted by y, and the expression for y is equal to 1 by 2 a t square. This gives 1 by 2. Acceleration is given by E by m, and the timing is total distance divided by velocity of the electron. And talking about the velocity, final velocity, when the electron emerges from the plates, the direction of velocity is different from the initial velocity. After emerging from the plates, the electron will have separate horizontal velocity and vertical velocity. There is no change in the horizontal velocity, so horizontal velocity is the initial velocity, but the vertical velocity is developed due to the force in upward direction. So applying equations of motions, we will get the vertical velocity Vy given by At, which is equal to E by m into d by v, and the direction of the velocity theta will be given by tan inverse By bx, that is equal to tan inverse E by m dv square. This is all about the theoretical concept on the motion of electron in electric field. Now we will use this concept to solve some numericals related to this topic. We have a numerical question. An electron is released in an electric field of strength 100 volt per cm. Calculate the kinetic energy gained by the electron while it moves through 10 cm of the field. So the provided electric field is 100 volt per cm. This is equal to 100 volt by 1 by 100 meter. This is 10,000 volt per meter. Calculate the kinetic energy gained by an electron while it moves through a distance of 10 cm, that is 0.1 meter. So when an electron is released in electric field, the kinetic energy developed in the electron will be equal to the potential energy provided by the electric field, which is equal to charge into potential. The charge of electron is E and the potential is electric field into distance. So this comes 1.6 into 10 power minus 19. Electric field provided 10,000 and distance 0.1. This is equal to 1.6 into 10 power minus 16 joule. Here is the second question. A beam of electron moving with velocity of 4 into 10 power 7 meters per second enters midway between the horizontal plates in a direction of the plates. The plates are 4 cm long and 2 cm apart and have a potential difference of 200 volt applied between them. What is the vertical deflection of the beam as it emerges from the plate? Now we will solve this question with respect to the above discussion. The two plates A and B the velocity of electron entering in between the two plates is given by B is equal to 4 into 10 power 7 meter per second. Now talking about the two plates, the length of the two plate is equal to 4 cm. .04 meter. The separation between the two plate is 2 cm, 0.02 meter, and the potential between the two plate applied is 200 volt. So the electric field will be potential applied by separation 200 divided by 0.02. We get 10,000 volt per meter. Now we have to calculate what is the vertical deflection of the beam as it emerges from the plate. So we have direct formula for deflection, which is equal to y is equal to 1 by 2 E by m. M is the mass of electron, d by v square. Keeping these values, 1 by 2, 1.6 into 10 power minus 19, electric field 10,000 by mass of electron 9.1 into 10 power minus 31. Length of the plate 0.04 by velocity of electron 4 into 10 power 7 square. We will use calculator to solve this. Half into the item between the bracket comes to be 1.758 into 10 power 15 into, and this becomes 1.1 into 10 power minus 18, and after calculating we get 8.79 into 10 power minus 4 or 0.879 into 10 power minus 3 meter. This can be written as 0.879 millimeter. This is the answer. Now let us start with the third question. A beam of electron moving with a velocity of 1 into 10 power 7 meter per second enters midway between two horizontal plates in a direction parallel to the plate. The plates are 5 cm long and 2 cm apart. When a PD of 89 volt is applied between the plates, the beam is deflected so that it just misses the edge of one of the plates. Calculate the specific charge of the electron. Here we are provided with two plates. The length of the two plates is 5 cm long, that is 0.05 meter, and the separation is 2 cm, 0.02 meter. This is the length, and this one is the separation. The electron enters between these two plates with velocity 1.0 into 10 power 7 meter per second. According to the question, what the question says, the electron enters midway, and the dotted line gives the path if there is no electric field between the two plates. Now if electric field is applied, the electron is deviated to the positive plate, and according to the question, what the question says, that the electrons emerges through the edge of the plate. So the deflection for the electron will be given by y is equal to d by 2, because the electron enters midway and emerges through the corner. So the deflection will be half of the separation between the two plates. This value is 0.01 meter. Now for this deflection, the potential difference provided between the two plates is 89 volt. So the electric field will be volt E by D, 89 by 0.02. This becomes 4450 volt per meter. Here we need to calculate the specific charge, or E by M, for the electron. Now we will use the formula for vertical deflection to calculate the value of E by M. The formula is y is equal to 1 by 2 E by M d by v square. Here almost all values are given. We will put the values and calculate E by M. Y is 0.01, 1 by 2. E by M is to be calculated. Electric field 4450. D is 0.05, and velocity is given by 1 into 10 power 7 whole square, or 0.01 2225 into E by M into 2.5 into 10 power minus 17. Solving this, we get E by m is equal to 1.797 into 10 power 11 coulomb per kg, which is the required answer. Here is another question. Electron with kinetic energy of 500 electron volt are projected between two parallel charged plates in a direction parallel to the surface. The plates are at a potential difference of 5 volt and 5 mm apart and 4 cm long. What is the angle the emergent P makes with the original direction? So first we will use here the kinetic energy of electron is 500 electron volt, which is equal to 500 into 1.6 into 10 power minus 19, 8 into 10 power minus 17 joules of kinetic energy. Kinetic energy is given by half mv square. So the velocity of the electron will be equal to 2 into 8 into 10 power minus 17 by m. Mass of electron 16 into 10 power minus 17 by 9.1 into 10 power minus 31, and this comes 1.325 into 10 power 7 meter per second. So this is the velocity of electron with which the electron will enter between the two plates. Again, according to the question, the electrons enters with velocity v inside the plate and is deviated due to the charge on the plates. Due to deviation, the angle the electron makes some angle theta with the original or horizontal direction when it emerges from the plate, and we know that the angle theta is given by tan inverse of EET by m v square. And from the question, the potential difference applied is 5 volt and the separation between the two plates is 5 mm, that is 5 into 10 power minus 3 meter. So electric field will be V by D, 5 by 5 into 10 power minus 3. This gives 1000 volt per meter, and we will keep this value tan inverse 1.6 into 10 power minus 19,000. The length of the plate is 4 cm, so 0.04 by mass of electron 9.1 in 10 power minus 31 and velocity 1.325 10 power 7 square. We will solve this value. We will get 0.040, and this comes to be 2.294 degree, which is the required answer.